here's where, since I'm going to, well, you have two options here. One, you could actually break up the surface layer by layer for each one of the decks. Or I know that these decks are at 2 meters off the baseline and then 5 meters, 5 meters, 5 meters. So I could either split the surfaces for the shell surface, or I could cut all the curves that I want and then simply split the curves. Now, if I'm going to split the surface, I would want to make a copy of it first so that I maintain the original. So instead of doing that, I'll go ahead and just split the curves for this section here. So to make things a little cleaner, let's make another layer, and I'll call this all curves. Make that current. And we'll just select the hull surface, the contour command, and again, we'll use 0, 0 as our base point and the x-axis, 1 meter spacing. And since we're going to be using mesh patch and the divide curve by length of segments, so I'll go ahead and I'll create this transom edge curve. And to extract an edge curve, this is another useful command you may want to use. It's again in the curve from objects, but you can do duplicate edge. Duplicate border will do all edges around the surface, but if you just want a single edge, you can do duplicate edge. And then since there are two edges there, we've got the edge of the transom and we've got the edge of the hull. Now here they're coincident, it won't matter which one you select, but we'll go and you can see which one it belongs to based on the arrows coming off the edge there. It points in the direction of the surface. So we'll grab the hull surface edge and select that one. So I created that on the hull curves, and we might as well also get the stem. And now we can turn off our surfaces. We can turn off our mesh for the main deck there. And we'll grab all of these curves, and probably the easiest way to cut them is to create a surface corner to corner. And we'll just make sure it covers the entire hull. And we can select that surface and use the set point command. And we will set the Z value of that cutting plane to 12. Just to verify that it's at the right height for the deck, we'll turn the surfaces back on quickly. And you can see that cutting plane is now coincident with the second deck. So that's where we wanted it. And now we can grab all of these curves and we use the split command, similar to trim, but this will split any objects that we have selected. And then you select the cutting object that's going to split them. And they all remain highlighted, but now they're broken. If I unselect from below, you can see it's only keeping the portions above that cutting plane. And what I might want to do here is highlight all of the ones that were below, and I'll group them and hide them, because we'll use them later when we create the lower decks. And it looks like back aft here, that last curve intersects the, what happened to my transom curve there? I never fully extracted the transom curve. I must not have. So let me duplicate edge. I think I never right-clicked on that to complete the operation. Now if I turn up, now I have my transom curve. So we will go in, recreate that cutting plane. Z, 12 meters. Grab all of our curves. split with the plane. You can keep the plane and group and hide all curves below the second deck. Now there'll be a slight issue in these bow curves, because as we select all of these curves, if we check the direction of them, all of them are starting at center line and going up, which is what we want. We'll use an even spacing for our mesh. When we're starting at center line and going up for the girth on the stiffeners here, these are going to be starting off of the stem, not at the deck. So the spacing when we get up into this area is going to be off. So what we'll do is we will grab all of the curves down to the deck and use the curve point object divide curve by length of segments. We'll stick with the 1 meter spacing that we had. And this is a mix of the nodes that were created as well as the control points on the curve. So when I click elsewhere, we just see the points that were created. Now you can see a lot of these points just have a little left over, and we really want that to be at the deck edge. When we turn on our deck mesh, we would wind up with a little sliver there. So we probably want to get rid of this top row of points, and it might be easier to do in this view. You can see how close they are. As we get further forward and the shear starts to pull away, we do get a little separation in there, but a lot of these points are going to be too close for what we want. So let's arbitrarily pick, this is 45 meters right here. We can see when we hover the mouse in the lower left, it's about 45 meters. So we'll keep it at 45, and everything after 45, we will grab that top row. Oops. Of those points. And again, it's getting very close in here, so probably want to get rid of some of those as well. And keep that one little try at the end there. Now for these sections up in the bow and on the stem, one thing that I like to do sometimes is just sort of extrapolate the curve up to the bow. And a couple ways of doing this. One, you can do this, and you may not even need to do this if you already have these curves from another 3D model, and you can export your stiffener traces. You'll already have them in 3D space, and you can use them. In fact, if you had the stiffener traces along the length of the hull, you wouldn't even need to cut these sections. If you had those longitudinal curves for your stiffener traces, you could grab all of those curves and run the contour command on those curves, and it would give you your point cloud here. And then all you would need is the points at the deck above and the deck below. But since we don't have those and we're essentially creating our stiffener traces, we've got a couple options here. We can grab these curves and extrapolate these points from this projected view from the side. If you wanted to get a little more accurate, we could turn on the surfaces, and again, would be intersecting with these curves. But what we could do is there is an option under the curves menu, and actually I think you can get to it from here. You can do interpolate curve on surface. So you can do for each one of these what is essentially going to be a stiffener trace. You select the surface we want to draw on, and you start clicking on a few of these points. I'm going to have it select points exclusively. It doesn't want to grab that one. It must be on the inside of the surface or something. Yeah. So I'll do 4 points. And we'll do it again. It's having difficulty finding these points because I'm on a solid surface. So I can change the view type under the window here. You can switch from a shaded view to a wireframe, which is what's displayed in the others. And that'll make this a little easier to do. And I'll create another curve. Now we should be able to extend on surface. So I just did 3 quick ones there. I believe there's an option to extend curve on surface. And so we want to select the curves we want to extend. I'll grab this one. Grab all 3. And then select the surface that they're on. And this is the surface. It says it broke the history on 3 objects, but if we look at it in a 3D view, they do hook down a little bit. So I don't know if that's necessarily the curve you want to use. If that is the actual stiffener trace, we're fine. If we don't like that, we don't have to use it. We could very simply, and this is so far forward in the bow, it's not going to matter for longitudinal strength in a global model. The quick and easy way of doing this would be to grab these curves in this view and then use the section command. And you can grab and extrapolate forward. Now I have orthogonal turned on. I'm going to turn that off so that I can, and I'm going to right click on point to turn back on those other options. And I want to catch the bottom of this curve at the stem. That way I don't wind up with a tiny little triangle there. Although if it wasn't quite right and I really wanted to keep it straight moving forward, I can pick another spot, but I'll go ahead and use that one. Go from this point to, say, there. And I'm just sort of trying to extend in the direction that the points behind might indicate. And I'll need a point at the bottom here. And for this section, the easiest thing to do is to do the section command again, but I'll just connect the points before and after. At that point, I probably don't even need to get rid of that. It'll just connect everything else. This will be a triangle, and then we'll get 2 quads at the end there. Final thing would be to select all of these curves, and we will check the direction again. Everything's pointed up. So the curves, we'll right click in the top, and actually I guess it's more than 10 commands. I forget how many it is total. It does have a limit in terms of how many it remembers. It might be 20 actually. But the one that we did was the endpoint. Maybe off the list now. So if we do curve, point, mark curve end, now we have all the points up at the deck there. Now, another thing you can do at this point was, I knew we had point-to-point connectivity on the surfaces. So we're going to have point-to-point connectivity on all of these section curves. If I was worried about it, and this is something that I will do quite often when I'm building bulkheads, is I will take the mesh points from an adjacent mesh and I'll use them rather than create new ones that should be the same points. What I'll do is I'll take this mesh and I'll use the curve from objects. It also allows you to extract points. So you can extract all of the mesh points from the mesh in here. But then it's a little bit of a pain because now you need to delete all of the ones that you don't want to use. So we have to grab all of these, delete them. And you want to be careful when you're grabbing these, because if you accidentally grab the mesh, you can drag it. Easy enough to undo in Rhino, but in Maestro, where you don't have the undo available, it's something you want to be careful of. At any rate, you get the idea. And then I would use the points from this mesh, create the other one, and that way you're guaranteed that the meshes will have point-to-point connectivity because they share the same points. these should be just fine. So again, we'll do select points, go into mesh tools, and create a mesh patch. Now, this is another thing that you need to be careful of when you do mesh patch. There is an option, I think, to give it a perimeter curve, or maybe it's the starting surface. If you don't, what it will do is it wants to make a mesh between any concave points. So it created this mesh down at the bottom here because there was concave surface where the shell was, but there's also a connection along this bottom row that is concave, and it decided to fill that in with a mesh. We turn on shading, we can see where it is. Now, there are a couple of nice mesh commands that can help out with this. It wasn't so much an issue in the back, although there was a little curvature from the transom. There are some extra, I think, tries at the end here. But let's clean up the mesh a little bit. Well, this is another problem. When it created this mesh, it made the tries in the wrong direction. We wanted that mesh longitudinally. Now we can fix that manually. Under the mesh tools, there is this option for swapping a mesh edge, and that will flip a mesh edge in there. Obviously, that's not something we would want to do on all of these. I'm not sure why it created it like that, but and you can see it didn't have that problem up forward. So if we were to grab this and say quadrangulate, it fixed all the ones forward. And maybe if we rebuilt this in a section aft, it wouldn't be an issue. But the other thing I wanted to mention here was that to fix this extra piece of mesh at the bottom, which is on a, it's basically part of the deck there, and it's at a 90-degree angle, there's an option in these mesh tools to extract a mesh face. Now, if you just click on one, it's allows you to extract one at a time. But there is another option where you can say extract connected mesh faces, and that goes with an angular tolerance. So we'll grab one mesh face, and then we'll set a 10-degree tolerance here. And if we say extract, now all of those additional ones that it created on the deck, we can simply delete, and now we just have our shell, which is what we wanted. And I think this happened also back here. So it made a little piece of the transom there. So we'll go ahead and extract that and delete it. Now, because it didn't make this aft portion of the mesh correctly, let's give that another shot. And I'll say extract the meshes, and instead this time I will use a window to select it, and we'll do everything back aft and even this row here, and extract and delete them. So now we can grab all the points, and then we'll unselect and unselect these, what we already have the mesh for. So now we just have the points aft, and we'll use the mesh patch command again. Now we get more what we want. So it was something that propagated through there, most likely because of those triangles at the bottom, but this is more along the lines of what we were expecting. So we can quadrangulate that. And now we have a nice looking mesh for the side shell. We can grab both of these two meshes, and in the standard menu, there's an option to join items, whether they're curves, surfaces, or even meshes. You can join those meshes. The bow wasn't quite what we expected here, so we can try and rebuild this again also. We'll extract all of those. Grab these points, remove the curves, do the mesh patch, and now we're getting what we wanted. So we'll grab that mesh, quadrangulate. Didn't get rid of all of them, so we can manually go in and use the merge command and just click on those extras. And that mesh and join. We still have a couple in here we need to fix. There's a couple of options for how we do this. We could destroy it, recreate new ones. You can create a single mesh face by clicking on a series of 4 points. You can add a mesh face, and sometimes this is a nice quick way of doing it. So if I go in here and I say delete a mesh face, and I'll get rid of these 3, there's an option to add a mesh face right next to it. And what you do is you click on one edge and another edge, and it just lofts across them. I can do that again here. And then I move to the next one. Delete these. Now, if this was a much larger opening, another option would be to enclose the end. So now it's a hole in the surface. If I were to, actually, let me show it here. There's an option here to fill a mesh hole. And I use this on the deck sometimes, and it'll do it with a triangular mesh. So you will need to go in and patch that. There's another one here we want to close. But now we have a pretty reasonable shell mesh. Now this looks like there's a reversal in normal there. So we can check with analyze direction, and we can see, yep, there are some bad normals in here. But what we can do is, and sometimes if they're flipped in opposite direction, there is a command for unifying mesh normals. So under the mesh edit tools, actually, I'm sorry, repair, there's a unify normals. So if they were in opposite directions, that would fix them. If we look at the direction again, you can see they're still looking odd in here. So it's not that they were flipped, they are in the right direction, they just don't seem to be in the direction that we wanted. So we'll go under mesh repair, and we'll say rebuild the mesh normals. And now if we view them, that's much more like what we wanted in here, and you no longer see that shading discrepancy. So that's an example for the deck, an example for the shell. And you can see, the points are a pretty good mesh to mesh or edge to edge connectivity between the meshes. And Maestro does have a 1 millimeter tolerance. So, as long as those nodes, even if they weren't exactly in the same spot, as long as they're within a millimeter, everything will be fine. They'll just get merged automatically. If we turn off these surfaces, you can see up at the bow, there is a slight mismatch here. And let me, for the curves, to hide them all. And this is where in Rhino, these mesh tools are very handy. There's a mesh tool here to split a mesh edge. So we can grab that mesh edge and select a nearby vertex to it'll project down. If I click on it, let me delete all the points. They're not in the way. So if we click on this mesh and under standard, turn on our control points, we can see our mesh control points there, and I can just drag it up onto the other mesh. And let's go ahead and subdivide this one as well. We can just manually pick a point in there that we like. And we'll go ahead and merge these. Now, that did a straight line connection, so it's got a little bit of a dent in the hull there. We could turn on the surface and do, I think we can project we can do a closest point to a curve. I thought you could also project on the surface. I know you can do it. There is a project, actually it's a pull command under curve from objects, pull back. So you select the pulling surface, which will be the hull here. Oops. Grab the curve there. I thought you could select a surface for that. I guess it has to be a curve. Do that. Regardless, we could do go from that vertex to that vertex. And now that we have that curve, we can do closest point. Select this vertex. That point there is actually the closest point. So if we turn these control points on, we can move that control point, which is now 3 mesh points. So we'll use a window to grab them. And grabbed our reference point that we were trying to drag it to. So turn off that gumball that's in the way. Drag that point onto this one. Now that point is on the hull. So it'll be a little smoother. Now, because there were multiple points there, this would be another one we want to divide. When we turned on the reference points, you saw there were 3 at that particular node location. And if we imported this into Maestro, there would still be 3 points there because they belong to 3 separate corners of the mesh there. One thing I like to do sometimes is to, and this applies also when you join meshes. If we were to look at these meshes, if we explode them, they will explode into the joined meshes that we created. So I'll undo the explode. So we're back into one mesh. And there is an option under Mesh, Edit, to weld selected vertices. And if you weld the vertices together, those meshes along the hull were joined together. The mesh on the deck and the hull are not joined. They're 2 separate meshes. So when I say weld all of these vertices together, it only applies within a given mesh. But now this one is a single mesh with 1 node at each location. So if I try and explode it, you can see it can no longer be exploded. It's 1 mesh. And it didn't try to merge the 2 separate meshes, even though the points were coincident, because they had not been joined. So that weld mesh nodes is fairly handy for consolidating the internal nodes in a mesh. That way, when you pull them into Maestro, when you go to edit and you need to move things around, it'll be a single node shared by all surrounding elements, as opposed to multiple nodes, one belonging to each element.